is about writing chemical formulas. So what we're going to do is learn about writing them as well as naming them. So what's a chemical formula? It's just a way to show the number of atoms in a compound. For example, sodium chloride, Na, there's one sodium atom. Cl, there's one chlorine atom. But down here with water, you'll notice there's two hydrogen atoms. How do we know that? Well, because the script tells us the number of atoms. What about a coefficient? So if I put a 2 right here, what that means is I have 2 sodium chlorides. I have 2 NAs and I have 2 Cls. So I have 1 sodium chloride molecule here and I have 1 sodium chloride molecule there. If you notice this special one here, I've got a polyatomic ion, all right, so calcium sulfate. And you'll notice that I had to put a subscript here after the parentheses, and that's because polyatomic ions act as a unit. So I have 2 sulfate polyatomic ions and 2 calcium atoms. So when I write a chemical formula, what I need is I need an overall charge that is neutral. To do that, I need to know the charges of the individual atoms. Magnesium, group 2, plus 2 charge. Bromine, group 1. Now that it's an ion, bromide, it has a -1. What I can do then is crisscross those charges, and that will tell me how many atoms I need. So magnesium needs to give away 2 electrons, but bromide can only accept 1. So I need 2 bromides to take those 2 electrons. We call that the crisscross method. So when I'm naming anions, I just add an IDE suffix. So I'm going to drop the ending, add an IDE suffix. Oxide, sulfide, nitride, phosphide, fluoride, chloride. Just like that. When I'm crisscrossing, lithium has a positive charge, just 1. Oxygen has a negative charge. So that oxygen needs 2 electrons. Well, it only gets 1 electron from a lithium. If I crisscross, so if I have a lithium here and my oxygen here, and I crisscross, I put this 2 for the lithium, this plus 1 for the oxygen, I'll have Li2. And I don't need to write the 1 because anything times 1 is 1. So now it tells me I need 2 lithiums in order to neutralize that oxygen. When we're naming some of these chemical formulas, we've got monoatomic names and polyatomic names and binary compounds and acids. So keep those in mind. We'll work through these 4 things. Start with monoatomic. Name the cation first. That's just the name of the element. Magnesium, potassium, hydrogen. For the anion, that's the negative one, we're going to use that IDE suffix. Magnesium oxide, potassium sulfide, hydrogen fluoride. For a polyatomic ion, we're going to treat these as 1 unit. And as a unit, they have a charge. So I might crisscross using that particular charge. That's why that chart's going to be so important. In order to kind of visualize or memorize some of these, it's important to know the naming. All right, more oxygen means ATE as the ending. Less oxygen, ITE as the ending. So, for example, chlorate has more oxygen than chlorite. But what if that's my standard or base naming? But what if I had even more than the chlorate? Well, now I need a hyper. So that's why we get a perchlorate. It has even more oxygens. What about a less than the normal? Less than the ite. So that's where we get the hypochlorite. So ionic compounds, metal plus a non-metal. Sometimes the metal is weird. That is, it has more than 1 possible charge. Like polyatomic ions, 1 possible charge. Magnesium and everything in group 2, 1 possible charge. When you get in the middle with all of the metals in there, they might have 2 or more possible charges, in which case we're going to use a Roman numeral. So for example, aluminum oxide, sodium chloride, copper 2 chloride. Now, how do I know that this is a copper 2? Well, the way I can tell is I can reverse my crisscross method. So I know that's a copper with a 2 charge. So I can use the Roman numeral 2 for that. All right, how about binary compounds? All right, these are molecular compounds, but it's nonmetals and nonmetals. All right, in this case, we're going to name them based on the Greek prefixes. So mono means 1, di means 2, tri means 3, tetra 4, and so on. So if you can remember those prefixes, that will help you figure out like how to name some of these compounds. Here's a few extra rules. Prefixes are based on the subscript, not the charges, subscript. All right, we never use mono in the first element. If we have an element that starts with a vowel, we're not going to have extra O's and A's in there. All right, so a mono and an oxygen, we're not going to have 2 O's. Okay, so just drop the O or A at the end of the prefix if it begins with a vowel. So dinitrogen pentoxide, monocarbon dioxide, or we might just say carbon dioxide, because there's just the one, and we don't use mono at the beginning. For acids, those are going to be a hydrogen plus a nonmetal. All right, if they're binary acids. All right, so binary acids have this one configuration, hydrogens and a nonmetal. All right, so we're going to start that name with hydro to represent the hydrogen. We're going to have the nonmetal root, and then we're going to have the ic, and then we're going to say the word acid. All right, so hydrofluoric, because that's fluorine. So hydrofluor, we're going to change the ending to ic, hydrofluoric, and then we're going to add the word acid. Hydrochloric acid, hydrobromic acid. And because I started those names with hydro, you know that they have to be a binary acid. All right, so we're just talking about those 2 things, those 2 elements in their binary acid. An oxyacid is going to have a polyatomic ion with oxygen. That's how we get the oxy. So oxyacids contain a hydrogen and a polyatomic ion. Here, we're going to change the polyatomic ion ending. So the 8s, the ones with more oxygen, they're going to get an ic ending. If it's an ITE, the less oxygen, we're going to get an us ending. All right, so we're not going to say the hydro because that makes it a binary acid. This is going to be with a polyatomic ion. So we're just going to say what the polyatomic ion is, and we're going to change the ending. All right, so carbonate, no, is carbonic, and we're going to say the word acid. Nitrite, so nitrite has less oxygen, 2 instead of 3. We're going to call it nitrous acid. So nitric acid would be HNO3, nitrous acid, HNO2. Now, there are some special cases. They're special cases because they're weird. They're weird because we don't really get to see this much in nature. So sulfuric acid, why? Because SO4. SO3, sulfurous acid. Phosphoric acid, why? Because PO4, that's the phosphate ion. So phosphorus acid is the PO3 ion. So I hope that helps a little bit.